is on advanced separation process. My name is Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation processes. So in this lecture, we'll discuss about various types of membrane, classification of membrane, and typical flow pattern for membrane separation processes. So let's first discuss about membrane types. Membrane can be classified as a nature of the membrane, structure of the membrane, geometry of their membrane, and transport mechanism of the membrane. From the nature of membrane, membrane can be classified as a synthetic membrane or biological membrane, where synthetic membrane further classified as a inorganic membrane or organic membrane, and inorganic membrane further classified as a ceramic membrane, inorganic membrane, metallic membrane, carbon membrane, zeolite membrane, and glass membrane, where structure membrane further classified as a symmetric membrane and asymmetric membrane. Asymmetric membrane further classified as a integral asymmetric membrane and composite membrane, or can say that thin film composite membrane, where on basis of geometric membrane classified as a tubular, hollow fiber, flat sheet, and spiral wound, wherein based on transport mechanism membrane may classify as a dense membrane and porous membrane, where dense membrane further classify as a solution diffusion method and facilitate transport method, where in porous membrane it depend on the Knudsen diffusion method, molecular sieve diffusion method, steric effect, selective surface flow. So these all methods are depend on the porous types of membrane. Mostly the membrane may classify according to their structure, such as a symmetric membrane and asymmetric membrane. So based on structure, symmetric membrane further classify as a homogeneous film membrane, cylindrical pores membrane, sponge-like porous membrane, where asymmetric membrane further classify as an integral symmetric membrane or composite membrane, where integral asymmetric membrane classify as a porous skin layer membrane or homogeneous skin layer membrane, where composite membrane further classify as a homogeneous skin layer membrane. In homogeneous film, there is homogeneous, or can say that uniform molecule structure throughout the membrane, where in cylindrical pores membrane there is a pores which shape like cylindrical, which look like this, where in sponge-like porous membrane which structure based on the sponge. So this is all about various types of membrane or classification of membrane. Now let's discuss in detail about this type of membrane. So let's first discuss about microporous membrane. A microporous membrane is a very similar in structure and function to conventional filter. It has rigid, highly void structure with randomly distributed and interconnected pores. However, these pores differ from those conventional filter by being extremely small, on the order of 0.01 to 10 nanometer in diameter. All particles larger than the pores are completely rejected by the steric effect. The microporous membrane further classified as a isotropic membrane and anisotropic membrane. In isotropic membrane, the pores are uniform in size throughout the membrane, where in anisotropic, the pores changing in size from one surface of membrane to another. So this is one example of the isotropic membrane, and this is one example of anisotropic membrane. In a isotropic membrane, the pore size, these pores of the membrane are uniform, or can say that near about the uniform in arrangement, where in anisotropic membrane the pores of the membrane is a different in shape. Here we can see that the pores of the membrane is very small. If you are going to the downside, the pores of the membrane is a increases. So this is one anisotropic membrane. So microporous membrane classified as a isotropic membrane and anisotropic membrane. In anisotropic membrane, pores of membrane is a uniform throughout the membrane, where in anisotropic membrane, pores change in size from one surface of membrane to the another. So this is all about the microporous membrane. Now let's discuss about the second important membrane, which is a asymmetric membrane. Asymmetric membrane is probably the greatest breakthrough in membrane research and development. Asymmetric membrane, also referred as a skin membrane, and they are characterized by thin skin on surface of membrane. Pore size in a asymmetric membrane is changed from 0.1 micron to the 1.0 micron. The layer under the skin may consist of void which serve to support the skin layer. Its separation characteristics are determined by the nature of membrane material or pore size, and mass transfer rate is determined mainly by the skin thickness. Porous sublayer act as a support for thin skin and the little effect on separation characteristic. This is a same image of the asymmetric membrane by solution casting method is developed. Asymmetric membrane are further classified as a integral skin membrane and non-integral skin membrane, where in integral skin membrane, skin layer resulting from phase inversion process which are porous, where in non-integral skin membrane, here skin layer are deposit from solution and are homogeneous in nature. So this is one example of asymmetric type membrane here, which is a dense top layer, or can say that skin, and this is a support layer, or can say that porous substrate. From these two parts of body, asymmetric membrane can form. Asymmetric membrane can further classify as a integral skin membrane, where the porous surface is a part of this membrane, where in non-integral skin membrane, this porous surface is made from the another solution. In integral skin membrane, skin layer result from phase inversion process which are porous, where in non-integral membrane, skin layer are deposit from solution and are homogeneous in nature. So this is all about the asymmetric membrane. Now let's discuss one another type of membrane, which is a thin film composite membrane. These are second generation membrane and are also referred as a thin film composite or thin layer composite membrane. Preliminary developed for the reverse osmosis and nanofiltration application. Composite have a thin dense polymer skin formed on the structure. Thin film composite membrane mainly made of three parts. Part 1, in which thin film selective layer, which pore size is less than 150 nanometer. Second layer of the membrane is made of polysulfone, polyether sulfone, polyamide, which pore size is less than 1 micrometer, which act for the support to the selective layer. So this layer is the use for the support to this the skin layer, or can say thin film selective layer. To support this layer, non-wound backing support, which pore size is 120 micron, is added to this membrane, which made of polyester. So this is all about the thin film composite membrane. Now let us discuss next membrane, which is a ceramic membrane or inorganic membrane. Ceramic membrane normally have asymmetric structure composed of at least two, but mostly three different porosity levels. Indeed, before applying the active microporous top layer, a mesoporous intermediate layer is often applied in order to reduce the surface roughness. So this is an example of ceramic membrane. So this is how the ceramic membrane, or can say that inorganic membrane, look like. The internal part of this membrane is or can say that mechanism of this ceramic membrane, which look like this image, where this is the pores of the membrane, or can say that channel. Retentant can be collected from the here, and permeate can be collected through this part. Solid content cannot pass from this porous membrane, that can be rejected and pass from this side, where the pure H2O or pure substance can be passed over this membrane surface. So this is about the ceramic membrane and mechanism of ceramic membrane. There are various applications of ceramic or inorganic membrane. Air separation by mixture of oxygen ionic and electronic conducting ceramic membrane and molecular carbon membrane. It's also used for the hydrogen separation by the metal, silica, zeolite and proton conducting ceramic membrane. Inorganic membrane or ceramic membrane, which also used for the hydrocarbon separation by the zeolite and silica membrane, and also used for the carbon dioxide separation by the silica or zeolite membrane. This membrane have a wide application in gas separation. Inorganic membrane are manufactured by number of methods. These include particle dispersion and slip casting method, phase separation and leaching method, anodic oxidation, thin film deposition and so on. This membrane offer sufficiently high permeation and selective for the targeted mixture and can be made into the membrane module for the practical application. However, a large scale application of inorganic membrane require further improvement in chemical stability and reduce in membrane cost. Porous ceramic in form of the thin disc have a potential as a new type of membrane which limit the commercial available polymeric membrane presently being used in low volume application for sterilizing filtration or particulate filtration. However, in order to propagate this approach, it is essential to resolve certain basic aspects of the ceramic membrane, such as scope of pore size, control and structure stability of the thin disc particulate due to the reduction in thickness and brittle nature of the ceramic material. While grain size of the powder is a critical in controlling the pore size and porosity, the grain size distribution and the sintering condition influence the maximum pore size. Although incorporation of the inorganic binder enhance the structure stability of the thin disc, it lead to the increase in pore size with reduction in porosity. So this is all about ceramic membrane and can say that inorganic membrane. Now let us discuss about the typical flow pattern in membrane. Ideally, there are four different flow pattern in membrane separation process. One is the complete mixing, second which is a co-current flow, counter-current flow and cross flow. In complete mixing, stirrers are used to the complete mixing of the feed side and permeate side. Where in co-current flow, the direction of feed and direction of permeate are same. Where in counter-current flow pattern, the direction of feed and direction of the permeate are different. Where in cross flow membrane, the direction of feed is like this and permeate can be collected in cross direction like this. So these four are typical flow pattern of membrane separation process which used in membrane assembly, and this is all about today's lecture. In this lecture, talk about the various types of membrane and consider classification of membrane such as on basis of the structure, geometric, transport rate and nature of membrane. Then discuss about the microporous membrane which further classify as a eccentric membrane and ineccentric membrane. Then talk about the asymmetric membrane which further classify as a integral skin membrane and non-integral skin membrane. Then discuss about the thin film composite membrane. Then talk about the ceramic membrane and discuss about the application of ceramic membrane and importance of ceramic membrane. Flow pattern in membrane separation process such as a complete mixing, co-current flow, counter-current flow and cross flow. So this is all about today's lecture. I am completing my lecture here. Thank you.